Hearing and vestibular sense are tested under the psychological, social, and biological foundations of behavior section of the MCAT. The exam doesn't just want you to memorize ear anatomy, it wants you to understand how mechanical sound waves turn into neural signals and how the same system helps you stay upright, coordinated, and spatially aware. So, let's break down how your brain hears and balances. The MCAT way. Hearing mechanism. Hearing starts when sound waves enter the outer ear and travel down the auditory canal to the tympanic membrane, also known as the eardrum. Vibrations of the eardrum move through the three ossicles in the middle ear, the malleus, incus, and stapes. The stapes then pushes against the oval window, transferring mechanical energy into the inner ear, specifically the fluid-filled cochlea. Cochlea and hair cells. Inside the cochlea, the vibrations travel through fluid and move the basilar membrane, which bends tiny hair cells, the sensory receptors of hearing. Each region of the cochlea responds to a different frequency. High-pitched sounds activate the base, while low-pitched sounds activate the apex. When these hair cells bend, they open ion channels, converting mechanical motion into electrical signals, the first step of neural transduction. Auditory pathway. From the cochlea, the signal travels through the auditory nerve to the brainstem, where it's partially processed. It then passes through the thalamus, the brain's relay station, before reaching the auditory cortex in the temporal lobe. That's where your brain actually interprets the signal as meaningful sound, speech, music, or ambient noise. Auditory processing in the brain. Different parts of the auditory cortex specialize in processing sound features like pitch, loudness, and location. The brain compares signals from both ears to locate where a sound is coming from, a process called sound localization. This complex analysis is what allows you to distinguish a whisper in a quiet room or follow a melody in a noisy crowd, all of which the MCAT might test conceptually in perception passages. Hearing disorders. Damage to hair cells in the cochlea is permanent. They don't regenerate. This leads to sensorineural hearing loss, often caused by loud noise, aging, or drugs. On the other hand, conductive hearing loss results from mechanical problems in the outer or middle ear, such as wax buildup or damage to the ossicles. The MCAT might test your ability to recognize where the breakdown occurs, mechanical versus neural. Vestibular sense. The vestibular system, located in the inner ear, gives you your sense of balance and spatial orientation. It works together with your vision and proprioception, body position awareness, to maintain stability, posture, and coordination. Semicircular canals. The semicircular canals detect rotational movements of the head in three planes: RALP, right anterior, left posterior; lateral, and LARP, left anterior, right posterior. Each canal is filled with fluid, and when your head moves, that fluid shifts, bending hair cells that send signals about angular acceleration. This is how your brain knows when you're turning or spinning, and why rapid movement can make you dizzy. Otolith organs. The otolith organs, the utricle and saccule, detect linear acceleration and changes in head position relative to gravity. They contain calcium carbonate crystals that shift when your head tilts or moves forward. This movement stimulates hair cells, signaling whether you're moving up, down, or leaning, critical for orientation and posture control. Vestibular pathway. Vestibular information is processed in the brainstem and cerebellum, which coordinate balance, posture, and eye movement. This system constantly communicates with your visual and proprioceptive inputs to keep your balance aligned. For example, if you spin rapidly and then stop, the lingering fluid movement in your semicircular canals is what makes the room feel like it's still spinning. Hearing and balance rely on one interconnected system, the inner ear, that converts mechanical energy into neural information. For the MCAT, focus on understanding pathway flow, outer to middle to inner and into the brain, mechanism of transduction, hair cells bending, and how the vestibular organs contribute to spatial orientation. These questions often appear as reasoning-based physiology passages, not just anatomy recall. With that said, here are just a few of our student success stories. Students who mastered these concepts, boosted their scores, and got into medical school. If you're studying for the MCAT, click the link below to get started with your own prep. We help students reach a 515 plus on the MCAT, and we'd love to do the same for you. And don't forget, subscribe to our channel for more MCAT breakdowns like this, and follow us on Instagram for extra tips and resources.